I will be looking at a NumPy library today. Okay, we'll start by saying we'll explain NumPy and its importance. I will look at the basis of NumPy, including its fundamental object. Then we'll demonstrate how to create and print a NumPy array, to analyze and perform basic operations in NumPy, utilize shapes, manipulate them, and use the copy method. Then we'll demonstrate how to execute linear algebraic functions. Then we'll build the program using NumPy. These are the things we'll be doing. Now, a quick recap on list that we did in our last two classes. Now let me create a list. Okay, say equals to, I'm having, let me say 12, 13, 17, 11. Okay, now, okay, this is a list. Now you find out that the properties of list are: one, they can collect values, collection of values, and another thing about list is that, let's say, another thing is they accept multiple types. Okay, that is heterogeneous data types. Now let's see. We saw that in our last class, so that is that. So let's get some things done. Let me create another list. 2, 4. Okay, now you can see another property of list is you can add elements to list, you can remove, and you can update. Okay, now these are the properties of list. And one of the limitations of list is that in list you can change individual value in a list, but you find out that you cannot apply a mathematical operation over the entire list. We'll be looking at an example. Okay, we've created a list here. Now I will show you the limitation I talked about just now. That list, you cannot apply a mathematical operation over the entire list. Now let's look at, we're given two lists here, speed and duration. Now let's run it. Now let's remember to run it. Then let's try and take a mathematical operation over the entire list. Let's say let's do the division. This is speed. Okay, let me call it result. Let me create result is equals to, let's say, speed divided by the duration. Okay, and this is what we have. Let's see whether this will work. Run. You can see the error here. Now this is to confirm that in list you cannot apply mathematical operation over the entire list. Okay, now that is why we've come up using the NumPy library. Now NumPy, what do we mean by NumPy? NumPy, when we talk about NumPy, we talk about numerical Python. It supports multi-dimensional array over which you can easily apply mathematical operation, unlike the list where you cannot apply mathematical operation on the entire list. And this NumPy is also known as an array, like list, but this is better. The NumPy is better. Now let's take so for example, let's take a walk through the NumPy library. Okay, let's see. Okay, let's call this thing again. Okay, let's just copy this. Just copy, paste. Okay, and now we run it. We're still using this for example. Okay, now I'll start now. Before you use the NumPy library, you start by saying import. You first of all import NumPy as np. Now np is an alias. Okay, now whenever you want to use NumPy, instead of writing the NumPy, we write NP, okay, to avoid complexity or whatever. Okay, so to avoid waste of time, so that we can be able to do things faster. Now you see, let's create something. Let's say, okay, once you're done importing this, you run it. Okay, you run it. Then let's create a variable. Okay, let's say NumPy speed is equals to, now whenever you're applying the NumPy, now we've said that let us represent NP whenever we are seeing NumPy. That's what this statement means. Import NumPy as NP. So now instead of writing NumPy, I rather write NP in place of it. That's why we call them alias. Okay, you can use them instead of. Okay, now you see this NumPy NP dot, you write array, then you put a curve bracket, then inside it you put the square bracket. But in this case, since we already have a variable holding a list here, we just, instead of putting this square bracket, we'll remove the square bracket, then we'll just indicate the variable, okay, itself. Now let's apply that to duration also. Let's say np duration is equals to np dot array, in bracket write duration, because we want to use this particular variable holding this value. Okay, now we will run it and see. But before we run it, let's just include everything here. Let's say let me still call the, or do I say speed? Okay, let me say distance. Let me say distance is equals to, now we want to divide this by this. We want to apply mathematical operation. Let's see what will happen. Now I'm calling this variable holding this NumPy value. So I say speed divided by np duration. Okay, now let's apply this and see what we'll get. Okay, we're not getting anything. What's the problem? Okay, now let's not forget, always comment on your code. Now let me try commenting on my code. Okay, sorry, let me comment on my code. Okay, now what we did here, we import the required library. Okay, let me comment on this place. What we'll do here, we'll say create create speed and duration NumPy arrays, control backslash. Okay, now let me take this off this place. I don't know why. Okay, let me cut it out. Okay, so I run. What I'll do here is paste this here. So distance holding this. So let me run it and see. Oh, still not getting anything. I don't know why. We're going to call the distance. We're going to call it for it to output. Okay, and you see we're having a result here. You can see we can perform mathematical operations on NumPy. Okay, now we move further. Now we say NumPy is the foundational package for mathematical computing in Python. It has so many properties. One of it is it supports fast and efficient multi-dimensional array. We can also call this array ndarray. Ndarray really means n-dimensional array. You can also perform linear algebraic operations on it, and you can generate random numbers. As we move further, you see how we can be able to use NumPy to generate random numbers, and it has an efficient way of storing and manipulating data, and it executes element-wise computation and mathematical calculation, and so many other. Okay, now let's look at some of the. Now let's look at some attributes, some classes and attributes of a NumPy array. Now let's let me make a heading here. Let's say classes and attributes. 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 Then one of the attributes we'll be looking at is n dimension. Okay, now let's apply the heading. Okay, now you see we'll be talking about sorry, less of ndarray, so that you know we're dealing with ndarray, as you can also call NumPy ndarray. Okay, now we're going to be looking at np, let's say car, np car. I'll be looking at how we can use this attribute n dimension. Okay, now let's create a NumPy array. I told you whenever you're creating a NumPy array, specify the np, and before you are specifying the np.array, make sure you have already imported it at first. Okay, then you put your curly bracket. Okay, now since we don't want to refer to any variable holding a list, we just put the square bracket which represents, okay, this is the format. So now we'll start inputting our elements. Now let me say Volvo, comma, we have Camry, comma, we have Benz, comma, we have what, Range Rover. Oh, I need to put, we have Range Rover, Range Rover. Okay, now okay, let me just put range. Okay, so now these are list of cars. Okay, and I've put it into a NumPy array. So now this is let me put it np. Now what do I want to do here? I want to see the dimension of this NumPy. Okay, let's see dimension. What we'll talk about dimension, it refers to the number of axes. That is the dimension. What we're talking about, what we want to go for the n dimension, talking about the number of axes of the array, and it is also called the rank of the array. Okay, now the way we can do it by applying this attribute here, by using the dot after calling your variable dot n dimension. Okay, now we'll run this and see the dimension of this. Now this is why we're getting an error. I always tell you, I remind you, always try as much as possible to run each cell. Okay, now many of us, I got complaints from the last class that this is throwing me an error, and I found out that many people don't run this cell, and that's why we're getting this error. You can see the error. Don't run away from bugs. Okay, when you get an error, try to verify what is the cause and try and resolve it. Now we're having an error saying name npcar is not defined, meaning this variable assigned to this value is not defined. We did not run it, so Python didn't have notice it. So let's run it, and we'll run this one too. You can see I told you this is the dimension of this array. Okay, so I told you it talks about the number of axes. This just has one axis, that's why it's returning us one at this as the output. Okay, now let's create something. Let's say npcar with color. Create another variable npcar with color is equals to, let me bring this. Okay, I say np.array, don't forget bracket. Okay, now this square bracket is the bracket that comes with you initializing an array. Okay, so since we want to create two arrays here, what we'll do, we'll put another square bracket, and let's say I want to copy this, let me paste it here, paste, then I go outside of the bracket, another comma. I want to put another paste here, let me say red, orange, yellow, then blue. Okay. Now I've done that, and let me run it. Okay, then I have to call np car with color. Okay, now I want to check the dimension. Okay, dot n dimension. This is the attribute we use. Now we'll see it. Let's see what it will return us. Now it's returning us 2 because we're having 2 dimension here. Okay, we're having 2 number of axes here. This is the first axis, this is the second axis. Okay, so that is why it's returning us 2. In this case, you can see it returned 1 because we're having just one axis. Okay, so let's move on to another attribute called shape classes and attribute of ndarray. Okay, now let's look at another attribute called shape. Okay, we run this. Shape, let's run. Okay, now we'll talk about the shape. It consists of a tuple of integers showing the size of the array in each dimension. Now we'll talk about this particular attribute talks about the length. Okay, all right. Now we're going to be looking at the shape of the tuples we created. Okay. Now let's do that. Now let's check the shape of npcar by using the dot shape attribute, and we'll see it will return a tuple. Okay, now it's returning a tuple. Okay, you can see. So it's telling us that the shape of this array is 4. Now you can see the npcar here has 4 elements, so it's telling us the shape is 4. And whenever it's returning a tuple, it comes with, after the number, you see a comma sign. Okay, so let's move further. Let's look at that of npcar with color. Okay, now we'll do the dot shape. Let's see, run it. You can see it's returning a tuple. It always returns a tuple for the shape. The output return a tuple, and this is telling us that this np car with color, you can see it here, which will initialize to this value. Now you can see it's telling us that these two represent a two axis. Okay, then the fourth telling us that each of the axes contain 4 elements. Okay, so that is it. Now let's move further. Then let's talk about another attribute called size. We're going to be looking at the size attributes of ndarray. Okay, size. Let's do this. Okay, now talking about the size, what this will give us is it gives us the total number of elements in the array. That's what it will give us. It equals the product of elements of the shape tuple. Okay, so it gives us the total element in the array, or you can say is the product of the shape tuple. Okay, now let's see, still using the same variables we've initialized up here. Now let's look at, okay, you can see, let's say np car dot size. Okay, let's see what it will return. It's returning 4. Remember I told you it gives the total number of elements in the array. Now you can find out that the total number of elements in the np car array is 4. That is why the size is returning 4. Okay, then let's look at the np car with color. Okay, with color, let's see what it will give us. With a dot size, and let's run it. You can see it's returning 8 because it's the total number of values in this variable that we created up here. You can see, let's count the total number of variables, elements, sorry, 1 2 3 4 5 6 7 8. That is why it's returning us 8. Or you can say is the product of the shape tuple. Okay, you can see 2 times 4 is 8. So that is it. Let's move further to another attribute called dtype class. Is an attribute of ndarray. This type. Now let's run it. Okay, I want to add more cell to this. Remember in our last class we say you do escape button, then to show you blue here, then you press B. As you are pressing B, it adds. Okay, so now we're going to look at the dtype, the data type of this. Now we discussed data type in our last class. Okay, so let me look at the data type of np car that I created. What you do is you can just write the variable and run it. Since we have initialized it, you can run it. You see now below here the output, you find out that date type, okay, dtype is written here. And now this symbol u5 really means this is a string. Okay, in some cases you see s whatever. Now why we are having this number 5 here is because the longest string in this array is having the length of 5. You can see Volvo is among the longest, Camry is among the longest, range is among the longest, so it's having 5. So that's what it's telling us. Okay, in some cases you not see u5, some cases you see s, so you know it's a string because it's having a quotation mark. Okay, now let's move further. So that this is the date type, it's a string value. Now let's still check. If you want to still check, you can still use the dot date type. You see to return it. Okay, you can see it's still returning what is here. So whichever way you feel like to check for the date type, you can. Okay, so you can do that for the MP car with color. Try that yourself. Alright, we'll move further. We'll look at some operations, some basic operations in NumPy. Now we have some operands, okay, that can easily apply various mathematical, logical, and comparison operation on array. We have the logical operators like the AND, the OR, the NOT, and the comparison operator like the greater than, equal to, like that. So we'll be applying them. We're applying the mathematical operators like the addition, the multiplication, the subtraction, the division, and the exponential sign. So let's see how we can apply some of these basic operation on array. Okay, we'll start by let's define something. Let's say first car owner. Let's define variable first car owners. First car owners is equals to, and let's give it an array. Okay, let's say 12, 15, 7, 9. Okay, so let's run this. So let's say another second car owners. Let's see, is equals to, let me say 5, 10, 13, 19. Okay, so we've indicated this. Now let's see how we can put this into an array. Okay, to use it for operation. Let's say MP. Alright, you see we've created a NumPy variable, okay, containing this list here. You can see I did an MP first car owners. We'll say mp.array. Then we'll call on the variable holding the list. Okay, we'll put it here, and we did that for the second variable also. So we want to see how we can apply some basic operations. Before that, I have to specify the heading here. So I did, let me indicate a heading here. Let's call it basic operations. Okay, so let's make it a heading, make it bold. So let me add more. Okay, so now you see we've created a NumPy array using the mp.array. Okay, calling our value we initialized here, first car owner, second car owner. Now I want to see how we can apply mathematical operation on them. So mp, okay, what do we call it? Okay, let's say mp first car owners plus mp second car owners. Let's see, want to add this, want to use the additional operator. Okay, so let's see, let's run it. Oh, we didn't run this, so let's run this. Okay, you see, is our answer. You see, we can do some basic operations on NumPy. Okay, alright, you can try using the multiplication sign, using whatever. Now you see, I use the addition sign here, the addition operator. You can see it here. So this is what happened. 12 plus 5, 17, 15 plus 10 got 25, 7 plus 13 20, 9 plus 19 got 28. So this is how it works. Okay, so the corresponding index will add the corresponding index of the order list or array. Okay, so this is what we've done. Okay, so we'll move further. We'll see how we can access array elements. Okay, let me indicate it here. Let's see how we can access array element. Access array element. Say we can also, there's another property of NumPy. You can access elements in the NumPy array. Okay, so let's see how we can access elements in the entire row of an array by referencing its access as is index. Okay, let's see. Okay, now let's create okay, let me make this. Okay, run, make it bold so that okay, now you can see we want to create a two-dimensional array. Okay, let's see how we can create a two-dimensional array. Okay, let's say cars owned. Okay, cars owned is equals to okay mp dot array curve bracket, then you put a square bracket. Okay, since we are creating a two-dimensional array, now note that this particular square bracket here is a default bracket that is supposed to be here when creating a NumPy array. So if we want to create an element in it, we want to create a two-dimensional array, we put another square bracket. So let's just copy these ones we used initially. Let's copy it. Okay, let's paste it behind it. We'll still create another one. Let's paste it. Let's copy this. Let's copy this one there. Okay, copy, and let's come here to paste it. Let's paste it. Now let's see how we can. Let's run this first. Let's run this, and let's see our first try how we can access these elements using. And now mind you, we access this array element using something I omitted here. I'm supposed to do something here. There's something I omitted here. Okay, this is supposed to be indexing. So we're accessing it by the index number, okay, like we did for list. So now we want to access it. Then let's call the variable cars owned. Now if you remember, we want to access in a list. In our last class we used this. Okay, if you can remember, we use the square bracket. Now we indicate the index number I want to output. Let's say 0. Okay, let's say 0. Now let's run it. Okay, we find out that it is our first list of arrays that we have here. Now the same thing applies. What we said about indexing in list still applies to NumPy array. Okay, now you can see this particular array is 0, this one is 1. Okay, so that is why we're having this particular element in this bracket, this first list here. Okay, this first array of elements. This indicates 0, this indicates 1. If we have another one like that, 2, as we go on. Okay, so that is why this is returning this first elements, list of elements in this bracket. So it's 0. Now let's use the 1. Let's see if it will return the other one. Let's put a square bracket. Let's put 1. Let's call it. You can see it's returning a second list of elements. Okay, a second array of elements. Now let's move further to accessing the individual elements in this array. Let's see how we can access the individual element in the array. Somebody's already said, how can we access the individual elements? Okay, now this is the answer to your question. If you want to access it, first of all, what you have to do is you first of all call the let's say cars owned. Okay, we'll call, first of all, you call the array, the first dimension, you call the particular axis you want. Okay, now we want to call this particular axis, we want to call an element. Let's say we want to call 15. Okay, so we call the particular axis 0, meaning since we say cars owned, but saying that, telling Python that this first list here, this first array of elements, we want to look for a number in it. That is why we are calling it first. Then if you call this, if you say cars own 0, index 0, it will point to the array that is the first, to the list that is the first in the array. So this is the first list in the array. So that is, our pointer has come here. Now I want to tell Python that I want to output 15. I want to access 15. Okay, and 15 in this place is having, let's count from here, 0, 1. 15 is 1. Remember our list, we'll say every index starts with 0, 0, 1, 2, 3. So we want to call 15, and 15 here is having an index of 1. Let's indicate it 1. Okay, let's see what it will give us. Okay, you can see we're having 15. Okay, we're having 15 in this case. So now let's move further. Now you can try that for other elements in the array. Now let's see how we can select all the rows of an array. Okay, let's see how we can select all the rows of an array. By selecting all the rows of an array, now this is what I mean. Okay, let's say we give it a, okay, let's still maintain the car owned. Okay, now we say we want to select all the rows of an array. Now this is how to do it. You put your square bracket. Remember, when you want to refer to anything in a list or in a NumPy array, you have to, if you want to index a particular number, want to access a particular thing, you use the square bracket. Always remember. Now this is what we'll do. Want to select all the rows of an array at once. We use a slicer. Remember when we did this, how to slice a particular range. So we'll be using that. We'll be using our column. What this means here now is by saying that from the beginning to the end of whatever we have in this particular variable, okay, you can see this particular variable here, we are having an array of numbers in 2 axes. Okay, we are telling Python that in this variable holding these values, we want to access from the beginning, the first array, to the last. That is what the empty here means, to the end. Okay, so now we place a comma here And the comma here is telling us that we want to access a particular index now. The next number that comes in is telling you the particular index you want to access. Now let's say you want to access the index of 0. Okay. First of all, we start by putting this column sign here. We are saying that from the beginning to the ending of this array, we want to access the whole array in this particular variable. And in the two array that we have here, if it's 2, 3, 4, 5, whatever, but we're having two arrays here, so we want to access their first element of each of the array. That's what the 0 here means. Okay, so let's see how this works. Okay, it's returning an error. Okay, while we are having this error, you see name car owned is not defined. Okay, it's true, we did not define car owned. What we defined was cars owned. So mind you, these are little errors you make and you become confused. Where's the error coming from? So let's take note of this. Okay, you can see now we have outputted the first element of each of the array. You can see 12 is the first element, 5 is the first element of the second. So this is how to select all the rows. First of all, if you want to select all the rows, first of all, indicate identifying it with the first number or whatever that comes before the comma. So in this place, we are using a slicer. Okay, we are slicing through, telling one from the starting to the end. That's why we don't have any number by the side of the column. Okay, so after that we put a comma indicating. Let's identify the second element in it. Let's see what we are going to get. You can see 15 and 10. So 15 here, we're having 10 here. You can see. So let's move further to slicing. Okay, slicing. Let's say accessing array elements. We're slicing. Let's see, slicing. Okay, using the markdown, run. Okay, so now we use the slicing method to access a range of values within an array. Okay, we access it. You can remember all these things when we did the list data structure. Okay, when we did the slicing, talk about accessing a range of value within that list. So the same thing applies to NumPy. Okay, let's see how we can access the range of values within an array. Okay, now let's say we're going to still use this particular. Okay, let me still call it here. There's no harm. Let me still call it here. Cars owned. Okay, you can see cars owned having two axes here. Okay, this is how it returns it. So now we want to see how we can access a range of value. Now we remember we talked about let me remind you about the shape of this. Let's see the shape so that it will not look as if now you see the shape here. Okay, so the shape of this. Now we are going to access a range of this value. Okay, now let me see range of cars owned. Okay, I want to let me call this cars owned. Okay, then I specify a range. Okay, let's say this. I'm saying that what I'm saying is, okay, let me just finish it. 1, Okay. Now what we want to say here, what we are trying to say here is we want to access this variable which we have here is from this place. You can see it, so don't be confused. So look at the output here. We want to access this variable, saying that from the starting, from the first to the last arrays of numbers in this array, that list of numbers in this array, we want to access the first, sorry, this is column. We want to access the first to the last, the first to the third element in each of them. I told you this column here without any number at the front or the back signifies that from the starting to the end of the list in the array, that's what it means. So then after the comma sign, we're having 1 column 3 means we want to access a range of value from 1 index 1 to 3. And mind you, I told you that when you are doing slicing, the last value, this number 3 is not inclusive, but the 1 is inclusive. Okay. Alright. Now, if you are confused, you refer to the last class. So the range cars owned. Okay. Then let me call it. Okay, sorry, we didn't run this. Okay, you can see it. You can see what we have here. Okay, from this variable here, we are saying that we are picking everything here. That is why we're having this, saying that each of them want from the first to the third, and the third we are saying is not inclusive. You can see the first index, the index having number 1 in this first list here is what 1 is 15, having 1 as the index. You can see it here. Then the next one we're saying 2 is 7. So we're saying that the third one should not be what? Should not be inclusive. Okay. The same thing applies to the next list of numbers in the array. That's why we're having this. I hope you understand. So let's move further. Alright, let's carry out an exercise very fast. You can pause the video and carry out an exercise. Select any 2 elements from the array to see. Okay, let me give you the array. Let's say new array. Okay, goes to NumPy dot array. Okay, let me give you the array. We say 6, 8, 10, 20. Okay, now what I want you to do here is that select any 2 elements from the array to see how the statement required to slice the range changes. Okay, now remember the rules. You have to choose the first element of the range, then you choose the element that ends the range, and you see how the values in the statement change according to your choice. Okay, so you try to do it again, refresh it again. Okay, let's see. Let me see. Just pause the video and do it, but let me carry out the exercise for you. Now maybe I have new array. I'm calling the value, so I want to take a range of let me say 2 to 3. No, 1 to 3. Okay, let's leave 1 to 3. Let's say from 0 to 1. Okay, 0 to 2. Let's see 0 to 2. 0 to from 0 to 2, the range of value that falls in that range. So mind you, 0 is inclusive, but the number having the index of 2 is not inclusive. So let's see. mind you, I have to always run every cell. Okay, you can see. So 0, the index carrying 0 is 6, it's inclusive. This is 1, this is 2. So the index, the value carrying the index number 2, which is 10, is not inclusive here. So that is that. So let's move further to assessing. Okay, let's see how we can iterate through assessing array, assessing array elements. Let's see how we can iterate iteration. Okay, now let's make this bold and to add. Okay, now we say okay, let's see how we can use the iteration method to go through each element present in particular data set. Alright, now we are still referring to the cars one. Okay, let's see. Okay, the cars one. Okay, we're still referring to it, so don't be confused. Now we want to see how we can iterate through, how we can look through it. Okay, we'll do that by saying okay, let's see, we can use the for loop to iterate through the entire data set. Okay, oh sorry. Okay, you can say for I, you can indicate this I to anything. You can say for cars, for car, whatever I want to say. In what you are trying to say is that for whatever, that's for the element, you are trying to say for the element in so and so. Okay, in cars owned, you can put this, you can indicate this as I, arrow, whatever. So I want to put it as car. So this particular thing means for the element in this particular variable having values that we initialize. So we are saying that print, sorry, first of all put our colon, don't forget. Then we are saying print. Okay, then you put your parentheses, print, you print this particular thing, you say for it. Okay, so we are saying print, this thing represents the elements, the items. So print cars, print car. Okay, so let's run it and see what it will give us. Okay, you can see. Okay, so even if we're having hundreds of lists inside the array, it will iterate through it. Okay, so don't forget, you can create a NumPy array where you have so many lists of elements. Okay, and you try to iterate through it. Okay, so now let's see how we can iterate through a particular data set using the for loop to select a particular specific element in it. Okay, let's see how we can do that, or you just try that yourself. Try and see if you can iterate through the data set using the for loop. Now let's move further to Boolean arrays. Okay, and let me say indexing with, can index with Boolean arrays. Okay, so let's control backslash, then I get this. Okay, run. Alright, I got something wrong here. Okay, so let's run it. We'll be looking at how we can use Boolean values how Boolean values are useful when you need to select a data set according to a set of criteria. Okay, remember the Boolean values are true or false. We said it in our previous classes. Now let's see how we can index using them. See, okay, let me start by saying, let's say score. Let me say mass score. Mass score is a test that took mathematics. So let's say np.array. Let's specify. Okay, let's say 30, okay, 35, so we got 67, 83, 47. Okay, let's see. Mind you, so we didn't create. Okay, so don't forget. Let's say 58, 67, 92. Wow, spacing got a nice mark. All right. We can see. The C is here. You can see it here. Okay. Let's run it so that it initialize. Now we want to see. Let's see past. Let's see past score. Those are past. Okay. Now we'll do a particular, when we want to return true or false, you bring a condition. So we want to bring a condition to this particular NP array. So let's say the condition I want to bring is, I want to say math score. I'm calling the variable that I initialize using this value. Math score that is greater than 50. 50 is a pass mark. Okay, greater than 50. Right, let's see. Okay, greater than 50. Oh, sorry. Why is this? It's a math score is not defined. Math score is not defined. Oh, you're making a mistake here. You can see this is math having S and this is not having S. Oh my god. Sorry about that. Run it. Okay, so having passed, we'll call the pass score. We have given it a condition. So let's see. Okay, you can see it will return only a Boolean. Okay, Boolean value. You see false, true, false, true, false. Now you can see, these Boolean values are returning according to these elements in this array. It's telling us that 35 here is false, doesn't meet up this condition. This other one here, 67, true, is greater than 50, met it, that's why it's returning true. 83 is greater than 50, it's running true. 47 is greater than 50, so it's returning false. Like that. So we have it here. This is how to return and to index using Boolean arrays. Okay, so now remember, this shows the data element which fits the criteria. Okay, so that is why we have it here. So let's see how we can send the score that passed, the people that passed, as an argument to the mathematics score. Okay, let's say I can just pass only those that passed. I can just put only those that passed, and let's do that by saying math score in bracket. You write past score. Then let's run it and see. Oh what am I getting wrong here? sorry, I forgot. This is supposed to be a square bracket. I told you whenever we're calling something, it's supposed to be a square bracket. Okay, so let's run it. Okay, now you see these are the scores that passed. I return the scores that passed using mass score in square bracket. We're passing the condition in it. Okay, is another one for returning this thing. Okay, now let's see how we can copy and view. Okay, let's see how we can copy and view. Copy and copy and view. So you can copy and view. Now, when working with array, just know that data is copied into new array only in some cases. Okay, this is well, there are 3 possible scenarios. Okay, so just get that into your head. And in this method, a variable is directly assigned the value of another variable, so no new copy is made. So let's see how we can do that. So let me start to defend that, like I said. Okay, I'm going to defend that. Now let's see how we can, let me add. Okay, let's see how we can defend that. Now remember, I told you when working with arrays, data is copied into new arrays. You can copy data by creating new variables, only in some cases. Okay, and there are possible scenarios that back in this particular thing I said. And a variable is directly assigned the value of another variable. So when we create a new variable, the value of that variable, we assign it to it, so the value automatically goes to that variable. Okay, there's no new copy that is made, no new copy. Okay, so let's see how. Okay, let's see states. Okay, states is equals to, these are states in Nigeria. Okay, so let's say mp dot, we are creating an array, mp dot. Okay, this is how to create an array. Let's say use Abia, Imo, Enugu, Zamfara, Abuja, Lagos. So these are created. Let's see how we can access this. Okay, let me call it mind you, most of you will return this while moving along with me, and you get an error because I started this with a capital letter. Remember, okay, so that you don't get an error. Okay, so that I didn't run this. Okay, so we've gotten our output here. So now let's see how we can assign a new variable to this. Okay, so let's say total states. Okay, is equals to states. Okay, so automatically the values of these has been assigned to this. This equals to sign represent to assign. So this has been assigned to this now. So let's run it and see. Run it. Then let me call the variable total state. Okay, you can see it has been returned here. Okay, so remember what I told you about the data type before. this means that these are string values, okay, and it has the longest element here has a length of 7. You can see 1, 2, 3, 4, 5, 6, 7. So that is it. So you can see how we assign a particular variable to an already initialized variable. So the values automatically goes to this. So no new copy is made. Let's show if what we said is true. Okay, let's say total, let's say total state is this is a built-in attribute, okay, in Python also. So just remember is it. Okay, now let's see what it will return for us. See, it's true because this is this. Okay, so that's why we're getting true here. All right, so you can see the copy and view. That is how it is. Now let's see. I've seen the copy. Let's see the view aspect of it. Okay, a view, which you can also refer to as a shallow copy. It creates a new array object. Okay, so let's see how we can look at this. Let's say to view. Okay, let's call a total state. Let's run it. You can see. So let's view it. Okay, let's say view total state. Okay, is equals to this total state dot. We want to use the view function to view it. I told you a view is just like a shallow copy. It creates another new array. Okay, I create a new array object. So just take note of that. Okay, let's see a total state dot. We want to use the view function. Okay, view. So let's run it. Okay, so let's check the length. By checking, if you want, anytime in Python, length is a built-in function, okay, for checking the length of anything. All right, so let's check the length of this view total state. Okay, let me copy the variable, paste it here. So let's look at it. You can see 6. The length of this variable is 6. Okay, let's say 1, 2, 3, 4, 5, 6. So the length is 6. Then let's see whether we can change. Let's see how we can change value in this view object. Okay, let's change the value. Okay, let's add more. Okay, scrub. Okay, now the view. Let me make a comment here. Change value in the view object. So let's see how we can change the value. Let's say I say view total state. Okay, let's see how we can change the value. I want to change the value of, let's change the value of emo to Benue. So emo here is having an index number of 1, 0, 1. Remember, so let's say 1. Then I change it to, I want to assign Benue to this index in this particular variable reviewed. So let's say Benue is a string, so you have to use quotation. Okay, without single or double quotes. Okay, So let's see. Now let's view. Let's output this. Okay, and let's run. You can see emo has been changed to Boolean. Okay, so you can try this. You can try it. You can use whatever array you want to use. Try it, and you will see that it will change. Okay, now let's see what we. Let's look at the original. Okay, let's look at the original data set that will change to this view total state. Okay, which was what? Which was the total state. Remember, it was this total state we assign the view using the view function. So whenever you use the view, you automatically create a new array. So let's see if that is true. Okay, let's use the original data set. Okay, let's see original data set. Okay, let's see what will happen. Let's see if this will actually be changed, because we say it will create a new array. Okay, like unlike this where we made a copy and you find out that it didn't change. Okay, it's still the same thing. So let's see view total state, view total. Okay, no, sorry. So let's check the original data set, which is total state. Okay, you see it has changed it. So the view function is used to change and create a new and create a new array object. But for the copy, you directly assign the value of another variable. Okay, so no new copy is made. So that is it. So let's move further and see. Now let's make use of still on the copy and view. Now if you want to make use of the copy function, copy is also called a deep copy because it entirely copies the original data set. Don't get confused. What we did here was we did a copy, which we did an assigning, okay, of a value in a particular variable to another variable. Okay, but in this case we want to do a deep copy using the copy function. Okay, you remember we didn't use the copy function at the top. Now I want to do a deep copy, okay, where the entire copies of the original data set go to the other data set. Now any change in the copy will not affect the original data set. Okay, so not in the case of view where it affects the original data set, but in the copy, we're going to do a deep copy. Let's see. Okay, let's say copy state. Okay, copy state is equal to copy state is equal to, let me copy this state. Okay, so let's see, copy equals to state dot copy. We use the copy function to copy it. Okay, so dot copy. So let's run it. Now let's look at copy state. Okay, copy state. Copy state is let's see if copy state is state Okay, you can see we run it, it's giving us a false here. You can see what we did is a deep copy, so any changes made in the copy will not affect the original data set. So you can see we did this, we did a deep copy, and we're trying to say copy state, is it the same thing with state? You see, we return false, you say no. Okay, but we copied it, we did a deep copy. So just take note, don't get confused. Okay, now let's move further. So what we're trying to say is that copy and the when you do copy, the copy and the original objects are different. Okay, they're different. All right, now we look at some other things. Okay, now let's change the value. Let's change the value. Okay, let's change the value. Okay, let's say copy. Okay, so let's say state. Let's say state. Okay, let's say state. Let's make changes. Let's say I want to change Zamfara to Niger. Okay, so Zamfara is having 0, 1, 2, 3. So 3 is equals to Niger. Okay, let's say run. So now let me. Okay, sorry. Let me just. Okay, since I've done it, let's see if. Sorry. Okay. Change it to states, right? Make call states. Okay. So it has been changed to Niger. Okay. So I want to call that copy that I copy, and let me see if the copy we hold the same value with it. Copy states. Okay. Why is it errors? Okay, you say copy state is not defined, and this is our error here. I use the capital letters or small letter. So you can see it retained what we copied initially. It didn't change because this one changed. So this is it. We did. That's how to do a deep copy. Okay. So we should not get confused. As we move further. We'll talk about the universal function. Universal function. Say NumPy provides useful mathematical functions called universal function, and these functions operate element-wise on an array, and they produce another array as output. Some of these functions, let's look at them. We look at functions like, okay, let's write universal function. Universal function. So we call them ufunc. Okay, so let's control backslash, create it as a heading, run it. Okay, we have a heading. Now we say that it's an universal function. This function operates element wise and produce another array as output. We say these functions include square root function. Square root function provides the square root of every element in the array. Like our mathematics, let me say np square root is equals to np dot square root. Okay, so you can see I'm not putting array in this case, so this is another function on its own. Okay, like I said, these functions operate element wise. They produce another array as output. Okay, not the same thing that is inside. Okay, these are universal functions. So let's write something. Find the square root of the following numbers. Okay, go to backslash and let's indicate the numbers. Mind you, operation of this, let's say 2, 3. Okay, let's say 2, 2, 2, 9, 16, 64. Okay, let's look at the square root. Let's run this. Okay, let's call it np. The square root is just like taking the square root in mathematics. Okay, you can see square root of this of 2 is this, square root of 9 is 3, square root of 16 4, square root of 64 8. Okay, these are normal mathematics. Python can make it faster for you. Now you can see is the output. Now let's look at another universal function, pi. Now let's say from NumPy let's import pi. Okay, so here we are importing pi. Okay, so for those who did not import pi. Okay, so let's run it. So from here, let's check. Since we import pi, let's check NumPy cos 0. So this library we're importing from NumPy, we're importing pi. Pi is under NumPy, so we're importing it so that we can be able to make use of this cosine, sine, and the rest. Okay, on these trigonometric functions. All right, so let's say we're having this. Let's run it. Okay, we're having 1. Okay, and let's see np dot sine let's say pi divided by 2. Let's see. Okay, so these are the functions. So let's see np dot let's say cos pi, cos pi. See, so now we're going to be making use of the floor function of our input wise. Okay, let's see what it will return for us. Now remember this, we're going to be using np.floor. Floor in this case means that it will return the nearest whole number. Okay, that is what we mean by floor. It will return the nearest whole number. So let's return floor. Okay, let's see something like 1.6. okay, comma 2.7, comma 3.2, comma 1.1, minus 0.5, comma okay, let me see, minus 0.4, minus 0.4. Just leave it here. Okay, oh sorry, I forgot, we have to put this is a NumPy function, so I have to put it inside the square bracket. Okay, so don't forget that. So let's run it. I told you what this floor function does. It return the nearest whole number downward. So let's see. Okay, you can see I return it 1.6. The nearest whole number downward is 1. You round it down, so it's 2.7 to 3.23, like that. You can see 0.4 minus 0.4 is minus 1. The nearest whole number downward. Okay, so if we want to see the exponential function for complex mathematical calculations, okay, we want to take, just say np dot transpose, then you put your, then you find your comma 1, 4. Let's see what is written for us. So this is the exponential function for complex mathematical calculation. Now we're going to be looking at the okay, let's see how we can manipulate our shape. Okay, how to manipulate shape. So say shape manipulation. So let's make this a heading. Okay, now let's see how we can manipulate shapes. Some of the methods for manipulating shapes are flatten it, split it, resize it, stack it, reshape it. Okay, so let's do that. Okay, let's see. We want to you can use a certain function to manipulate the shape of an array. By doing this, let's say, okay, let's say I have an array of numbers. Okay, let me just say new numbers, and I say equals to np dot array, and I put this. Okay, let's say I want to put 2 dimensions, 12. Okay, let's say 11. Okay. Now, whenever you're doing it, make sure it's containing the same amount of numbers, the first one and the second one also. Okay, having 4, 5, 6. Okay, 3, comma. Okay, 4, 5, 6. Okay, so we're having the same amount of numbers. Now let's see how we can, let's run this to initialize it. Let's see how we can flatten the data set. Let's see how we can flatten it. We'll use the ravel function. Okay, so let's say new numbers dot, let's say ravel is used, this ravel function is used to flatten it. Okay, let's see. You can see flatten means we try to make all of them to become one. Okay, because if you have to return this new number, I told you this number like this, they are in axis. This is first axis, second axis. Let's return, you see, sorry. Okay, you can see first axis, second axis. So we flattened it to this. So this is how to flatten the data set. Now I want to reshape it. Okay, this data set that you see like this, we want to reshape it. And now if I want to reshape it, I'm having 1, 2, 3, 4, 5, 6, 6 number each in it. So if I want to reshape it, I can say, okay, let's say reshape the data set, so that we'll know what we're doing 3 rows, 3 rows and 4 columns. 4 columns. Okay, so let's see how we can reshape it. New numbers. So you say dot reshape and bracket. You are saying 3 rows, 4 columns. So let's reshape it. Let's see how we can reshape it. So now these values now that you can see here, I have reshaped it. I've changed it to 3 rows, 1, 2, 3 and 4 columns. Now whenever you are doing this, you have to know your multiplication error, because here we're having 6, 6, 12. So multiple of 12, we know that 3 multiplied by 4 will give us 12. 4 multiplied by 3 will give us, so 4 and 3 matches. Okay, so that is that. You cannot come and use, let's say you want to come and use 7, 7 and 4. Let's run it and see. To give you an error, you can see the error here. It says cannot reshape arrays of size 12 into this. But we can do, let's do 6 and 2. Okay, or let's do 2 and 6. 2, 6, telling us that we need 2 rows with, okay, no, let's say we need 6 rows with 2 columns. Let's run it and see. You can see it. So you have to know your multiplication and division for you to reshape. Okay, so now let's use the resize. Let's resize to 2 rows and 6 columns. Let's resize again. Resize again to 2 rows and 6 columns. Okay, let's resize it. Let me copy this very fast. Copy and paste here. Dot resize. Okay, I'm using the resize function. So what am I resizing it to? 2, 6. So let's see. Let's put here new push. Okay, so let's see. I've resized it. Numbers. So let's see. Try to change back. Okay, see, I've resized it to 2 rows and 6 columns. Okay, so this is how to do it. So now I want to do a horizontal split. Okay, we split the array into 2. Let's see how we can do that. I'm using the, let's split the array into 2 by using the horizontal split. By using the np dot horizontal split. Okay, and bracket, let's paste that. Okay, oh sorry, we want to split it. You write a number of what you want, how many this you want to split it into. I want to split it into 2, so I mentioned it there. So you see, I split it into 2. You see, this is the first one, this and this is the first one, this and this is the second array. So I split it into 2. This is the horizontal splitting we're talking about. You can see it from here, splitted, here splitted, join itself, here splitted, here splitted. This is the horizontal splitting. So let's let's move on. You see, I want to do the stacking. I want to stack. Okay, now let me separate this. Let me say stack 1 is equals to, let me take these, I don't have to go over and over again to create this thing. So let me copy stack 1 np.array, put it into my array, so paste. Let's say stack 2 np.array. Let me copy the other number. Copy and paste. Then I run. Then I'll say let me stack it to, let's stack the array together. Let's stack the array together, okay? Let's stack it together by using the np dot this is a horizontal stacking, okay? So this is the horizontal stack in bracket. You paste the two variables. The first one, bring it here, then copy this one also. But before you paste it, you put your comma. You see? So let's run it. Gosh, we're having a problem here. So you see, what was the problem? We start dispatcher 1 positional argument, but 2 were given. What we have to do here is you have to put this. And whenever, now listen, now let's go over it again. Whenever you are having this function, okay, stack horizontal stack is a function. So whenever you are having two variables that are holding values in a particular function, you have to indicate, you have to the normal parenthesis and the parenthesis holding the two, like we did every time we're doing an array. Okay, so this is it. Don't get confused. So that's why we're returning this error for us. Now let's see. You can see. So anytime you are having multiple lists in a particular function, you have to do it. You have to put double parentheses. If it's the case of an array function, you have to put double square bracket holding the entire one, then the one holding it individually. So that's what happens here. So that is it. Now we are going to look at some few things before we round up with the class, which are we're going to look at broadcasting. Okay, now broadcasting, we say broadcasting, NumPy uses broadcasting to carry out arithmetic operations between arrays of different shapes. In this method, what happens is NumPy automatically broadcasts the smaller array over the larger array. I'll make you understand in case you're. So let's create two. Let's create two. Sorry. Let's create two arrays of the same type. We are going to create two arrays of the same type. So let's say array 1. Yes. Now we've created two arrays. Now let's run it. We've created two arrays. Now what we want to do broadcasting. We say broadcasting is to carry out arithmetic operation between two arrays of different shapes. Okay. So in this case, we see. Let's first create of the same shape, and let's see what happens. Okay. So they will write array 1 multiply by array 2. Okay, let's see what happens here. Okay, you can see the multiplication that goes 2 times 6, 12. So the anytime you're using any operator, arithmetic operator, what it does is each index for itself. Okay, so let's see. We want to create a variable with a smaller value. Let's see how it will work. Let's say array 3. Okay, let's give it a value of 3. Okay, now let's use it to multiply. Alright, so say array 1 multiply by array 3. Now you see they are not of the same size. Array 1 is having 4 elements, array 3 is having just 1 element. Let's see how array 3 is not a NumPy array. Okay, so let's see how this works. Okay, that means what happens here is that the smaller one overshadows the larger one. Okay, so that's what we're saying. The smaller array over the larger array. So you can see these 3 multiplied by 2, 3 multiplied by 3, 3 multiplied by 4, 3 multiplied by 5. So that's all good. You can see it. So that what broadcasting does. Carries out arithmetic. That's the only possible way in which you can carry arithmetic operation of different shapes. Okay, if not, it will not work. So that is it. Okay, so let's see. Mind you, what happens first here? I told you the mapping is directly to index. Here, what happens is broadcasting. Broadcasting is being done. Broadcasting was done by 3 to 2 to 3 to 4 to 5. That is why we're getting this output. That's the reason for the broadcasting. So now let's see. Okay, now broadcasting constraint. Say through broadcasting. Okay, can carry out mathematical operation between different shaped array, and they are subject to certain constraint as we've seen below. Okay, now let's see. Okay, we've created. Let's avoid creating another array. So we have this already. So we are saying that if we multiply it like we did, it will give us an answer. Okay, so let's see if we create an array of a different shape. Let's create an array of a different shape. I'll see. Let's create an array 4 mp dot array. Okay, let's say 5, 6. Let's say 5, 6, and let's run it. So let's see here we are talking about okay, mind you, I have to specify what I did here, okay, so that we avoid. Okay, we are doing broadcasting. Okay, broadcasting. So let's make this okay. All we want to do here is broadcasting constraint, so that when you are studying, you know what you're doing. Broadcasting constraint. Okay. So let's see how the constraint can apply. Let's see. Okay, let's see how we can say array 1 multiply by array 4. Okay, what happened? You see, it's giving us an error because why? I say this broadcasting is to some extent. Now you cannot have an array with 2 elements and you are multiplying it with array of 4 elements. Why we succeeded here was because this is just a number, a value 3. It broadcasted. When you talk about broadcasting, giving out to different places at a time. Okay, but in this case you cannot broadcast because this is an array. Okay, so you can say if the shape doesn't match with the array, the NumPy doesn't create any copy of another scalar value. Instead, what happens now? The broadcast scalar does what? Over the entire array. Okay, to find the product. So that is what happens when I did this. So this just overs it. It didn't match with the array. It didn't match with the array, but it's broadcasted. So now this one, we're having an error here because when NumPy operates on two arrays, it compares their shapes. Okay, it compares their shape. Their dimensions are the same, or one of them has a dimension of size 1. Alright, so this is what happens. So this is an array and you are using it to multiply, but in this case it's just a single number. So that is why it worked, and that is why it didn't work here. Hope you understand. So if you don't understand, you can just visit the link below. Now please, if you have not subscribed to my channel, please do well to subscribe and like the video. I want to see your comments down below. Okay, so alright, now let's look at an example to see how broadcasting work to calculate the number of working hours of workers per day. Okay, let's see how I can calculate, because that has been in my mind. Okay, so let's see how we can do that. Okay, np workers per day is equals to np.array Okay, so let's see, let's run it. Let me get the total any is equals to this. Copy this. It's not a good idea to copy. Paste plus copy this, copy, paste. Okay, and then I return the total you can see. Okay, you can see this. We can still see. We can still do total earning divided by 15. Let's see what it will give us. You can see, since we are using you are calculating by particular this, you can see there's no error, it's not throwing us an error. Okay, so let's finally look at okay, we still have one more thing to look at. Let's look at transpose. Okay, let's look at transpose, how we can transpose. So NumPy can carry out a linear algebraic function as well. The transpose function can help us to interchange rows as column and vice versa. Okay, use it to change rows as column, columns as row. Okay, let's say let's use what we used here. Okay, let's create something. Let's say test score is equals to np.array. I want to create a two-dimensional array. So let's say 83, 71, 45, 60. Okay, let's say comma this. Let's say 45, 87, comma. Okay, so we've created this. So now I want to transpose it. What I will do is, let me return this test score first, so that we'll know what we did. Okay, you can see it here. So you can see these are columns, while these are rows. So transpose, what transpose does is that transpose changes the columns to row to column. Okay, the transpose is a transpose function. Okay, so let's run it. You can see now all the columns now becomes row. 83 becomes 0. This is a column, this is a 83 and 45 now becomes 0. 71 and 67 becomes 0, like that till the end. Okay, now let's look at the inverse and the trace function. I think that's the last we'll be talking about today. The inverse and trace. Inverse and trace function. We use NumPy. With NumPy you can find the inverse of any array, and you can also add its diagonal data element. Okay, like we said, like matrix. We did matrix in our further mathematics or elementary maths. You find out that you can do inverse of a matrix. You can multiply it or add it diagonally. Okay, so now let's see. We can do that by using the NumPy dot. We can apply this in linear algebra. Okay, we can apply this in linear algebra. So we use this inverse. Okay, linear algebra. Okay, you can say inverse of what? Let's say inverse of we have test scores. So let's use test score to avoid creating another array. Test score. Okay. See. Oh, sorry. Telling us last two dimensions of the array must be square. Let's just get something prepared there. And doing that, okay. Let's say price is equals to, let's say, np dot array this, let's say, then 20. Okay, comma 50, 30. Okay, let's see. Now let's apply this function. What's inverse? So to check the inverse of these prices. Okay. Why are we getting an error here? Okay, you can see the error we're getting is a singular matrix. Okay, now this can be applied only on squared matrix. It cannot be applied on singular matrix. Okay, so that is why. Now let's see how we can apply trace. Can you see? So I've gotten so now we'll move, like I said, we're going to move to trace. Okay, trace. Where I want to do the trace, we say okay. Now let's just comment this trace function. Okay, so there's the trace. You can say np dot trace plus for price. Okay, you can see it. The sum of diagonal elements. Okay, you can see the sum of diagonal elements is. Okay, let me just put it so that it's not confuse us. Let's say price. Let's put this price so we can view it very well. Now you can see the sum of the diagonal elements. Okay, so that is what will happen. And that's what we're getting, 35 here. You can see 10 plus 25, 35, 30 plus 10 here, 20 plus 10 here, 20 plus 15 here. So the trace does the sum of diagonal elements. Okay, so that is that. So that's all for this course. Thank you very much for paying attention. Thank you for following me, for allowing me to hold your hands through this course. And I will still remind you, please try and subscribe to my channel, and also if you have not done that, also like. And I want to see your comments in the comment section of what you want me to do or where you are confused. Alright, thank you very much. See you.